Hello students, myself Gunjan Mittal Roy in the Department of Electronics and Communication in GEMTech Greater Noida. Welcome to the next video on Analog Electronics 1, and in this video I am going to give you an explanation on cascade and cascode amplifiers. These are the amplifiers which are most widely used in audio systems, in public address systems, and these are used in the Unit 1. So, considering the cascaded amplifier, cascade is nothing but the two transistors or amplifiers when connected in series, one after another, they are considered as cascaded configuration. And in the cascade form, we have number of configurations such as RC coupled amplifiers, transformer coupled amplifiers, direct coupled amplifiers. Out of all these amplifiers, we have RC coupled amplifier as a cascaded amplifier in our syllabus. So this is the most common type of cascaded amplifier, and it is very important for the examination point of view also. So in a two-stage RC coupled amplifier, the two transistors connected in common emitter mode with having all the biasing elements, which are potential divider biasing and self biasing, along with the coupling capacitors, are used. So as you can see in the diagram of the presentation, that the first stage is exactly similar to the second stage, with the difference that the input voltage or AC signal is applied to the base terminal of a input stage, whereas the output voltage, which is the magnified voltage, is obtained across the collector of the second stage. And the two stages are connected in such a way that the output of first stage, which is the collector terminal, is connected to the input of second stage, which is the base terminal. Now the connection elements are resistors RL and capacitor CC. So therefore the two elements R and C are used to couple the two transistors, and that is why the name is given as RC coupled amplifier. This is the amplifier which is used in audio systems for mid-frequency ranges, audio ranges. Now the RC coupled amplifier is very simple and genuine amplifier in terms of giving good amplification and good stability, and here is a excellent frequency response which we obtained through RC coupled amplifier. These are cascaded because of the fact that the first stage or only one stage, if not capable of delivering sufficient magnitude of amplification, then connection of the two stages brings a multiplication of the two gain factors. So let's say if the gain of the first stage is A1 and the gain of second stage is A2, then the overall gain of the device of a RC coupled two-stage RC coupled amplifier would be A1 into A2. Or in decibel scale we can add them. If the two gains are given in decibels, so simple output gain will be the addition of the two. So in other words, the two-stage RC coupled amplifier or cascaded amplifiers are used to enhance the gain of a circuit, gain of an amplifier. And now, apart from the gain characteristic, which is the most desirable feature of an amplifier, we also study the behavior of the frequency response. Okay, so this is the graphical representation of the frequency response of RC coupled amplifier. This response is divided into three parts, which are low frequency range, middle frequency range, and high frequency range. The low frequency range is considered from 0 to 50 Hz. The middle frequency range is nothing but the ideal audio frequency range, which is considered between 50 Hz to 20 kHz. Sometimes it is shown as between 20 Hz to 20 kHz, and the high frequency range is above 20 kHz. As I mentioned you that this is an audio amplifier, so it must amplify the signal effectively for the audio range only, and for the remaining ranges, that is the low frequency range and high frequency range, the gain should not be high, or sufficient in magnitude. So we can easily observe with the graph that the gain is definitely high for the middle range or the audio range, which is the desired range, and before that range and after that range it is rolling off. So as it is mentioned by the arrows showing the low frequency roll off and high frequency roll off, the gain drops at low and high frequencies. Now we should consider the fact that why there is a roll off at low and high frequencies. So this should be considered while giving the explanation on frequency response of RC coupled amplifier, that why the gain is rolled off at low and high frequency and it is constant for the middle frequency range. And before we go to that discussion, let me tell you that this is the ideal or the best frequency response for an amplifier, that whatever is the range of the frequency in which it is working, the gain should be constant, the gain should be flat. So we are having a flat gain for the desired frequency range and roll off for the undesired, unwanted frequency ranges. So this is considered as the best frequency response, and this flatness of the frequency response is known as the fidelity. So it is also called as the high fidelity response, and in short form this high fidelity response is considered as hi-fi systems. So the music systems, the audio systems which have the amplifiers having high fidelity, they are considered as the hi-fi systems. Now we come to the fact that why there is a roll off at lower frequency ranges and high frequency ranges. So for that, this is given in 3 sections as I told you. So the first we will discuss about the low frequency range. At low frequency ranges, the coupling capacitors offer very high reactance. We know that Xc is 1 upon 2 pi Fc. Xc is the reactance of a capacitor, and it is reciprocal to the frequency. So at low frequency the reactance becomes high, and if it becomes high, it is nothing but a kind of impedance which resists the signal to flow, which resists the current to flow in the circuit, and therefore at the output the voltage becomes low, resulting into the low voltage gain, or in other words we can say resulting into the roll off of the gain. So the reason behind the roll off at low frequencies is the reactance of the coupling capacitors, which is very high for low frequency ranges from 0 to 50 Hz. Now for high frequency, we consider the high frequency ranges which is above 20 kHz. The coupling capacitance definitely becomes reactance of the coupling capacitors becomes small, and they behave as a short circuit, no doubt in it. But now the Miller effect comes into the picture, which is the junction capacitances, and the junction capacitances add up and result into the large reactance, and gives rise to the roll off in the gain. So the low frequency at low frequency band, the reactance of coupling capacitors is high, whereas at high frequency not only the Miller effect but also the loading effect becomes high. So due to these factors the gain rolls off at high frequency ranges. Now if we consider the band from left to right, if there is a factor which is increasing the gain, if we go on from left to right, there is one factor by which the gain is increasing continuously. This is the reason why the gain increases, that if we go on increasing from 0 to higher frequency ranges, the reactance of the coupling capacitors becomes low, and it gives the relatively high voltage gain. So the voltage gain increases as we move on from left to right, or as the frequency increases the voltage gain increases, and the voltage gain increases because of the fact that the coupling reactance decreases. Now so there is a one factor which increases the gain with the rise in frequency, but there is one more factor, and due to this factor the voltage gain also increases if we go from right to left. That means the loading effect increases as the frequency increases. So if the frequency decreases, that means if we go from right to left, this loading effect also decreases. So if we consider the two factors, by one factor the gain is increasing and by the other factor the gain is decreasing. If we move on if we keep on increasing the frequency, if we move on from left to right. So if the frequency increases, there is one factor due to which the gain increases and there is one factor due to which the gain decreases. So there are two factors acting oppositely for the increasing frequency range. So for the middle range of the frequencies, which is from 50 Hz to 20 kHz, the two factors act oppositely in such a way that they cancel each other's effect, and resultant effect is a constant voltage gain. So this is done beautifully, that two factors work in opposite manner and the one factor increases the gain, other factor decreases the gain, and the resultant effect is a constant of flat gain, which is the desired response of frequency. So these are the three frequency ranges, behaviors. Now we have the advantages and disadvantages and applications of RC coupled amplifier, which are most commonly used in examinations. So the advantages, as I told you, the beautiful frequency response, and the circuit is simple and it has a lower cost because it employs simply resistors and capacitors. And it becomes more compact with the upgrading technology. That means if we use the nanotechnologies and the chip technologies are higher, then the size of the circuit can also be reduced. But the drawbacks are like firstly the voltage and power gain of the these devices are relatively low, and they become noisy with the age, and they offer poor impedance matching. This is the most considerable drawback, that the RC coupled amplifier does not offer good impedance matching with the load. And in audio amplifiers, load is nothing but the loudspeaker. So the impedance of the loudspeaker should be of the order of few ohms, and in case of RC coupled amplifier, the impedance is the output impedance is of the order of kilo ohms. So there is not at all a good impedance matching of the output of the transistor with the load. Therefore, the power delivered to the load could not be maximum, and therefore it is not at all used at the output stages of an amplifier. Now the applications, they have what means excellent frequency responses. So they are used for audio ranges and used as voltage amplifiers. But due to poor impedance matchings, they are rarely used in the final stages. So this is all about the RC coupled amplifier, which is the cascaded amplifier. Now we come to the cascode amplifier. So the cascode amplifier is again two-stage amplifier, but here the two stages are in a vertical mode. That means they are connected in vertical manner. That therefore one is the common emitter and the other is the common base. Similarly, we use FET, which is the most popular choice of a cascode amplifier, is common gate and then common source amplifier. And now they have they offer very high advantages, which are better input-output isolation, better gain, improved bandwidth, higher input impedance, higher output impedance, better stability, better slew rate. So there are so many advantages. Along with that, they offer increase in bandwidth, which was reduced due to the Miller effect. So the Miller effect, as I told you, is due to the junction capacitance is formed, and which offers the roll-off in the frequency band. So the cascode operations, the cascode amplifiers basically offer to overcome the Miller effect. This is the diagrammatic representation of cascode amplifier. So these are cascode amplifiers and cascade amplifiers. Thank you so much.